So this is Cambridge GCSE or the A level of this type of curriculum, and I have been told to find F double prime or, of course, with respect to change in x, the d2y over the dx2. And the question given here is a third x cubic less a half x squared plus x minus 6. So that is our question. We have been told find f2 prime with respect to change in x, or find d2y or d raised to 2y then dx raised to 2 of this equation. So you're supposed to actually understand that we are going to differentiate this equation 2 times or twice. We shall first be able to get f prime with respect to change in x, or what we refer to as dy dx. So we have been given the equation of fx as a third x cubic less a half x squared plus x minus 6. So this is fx, the equation or the function of f in form of x. We are supposed to get f2 prime with respect to change in x, or the d2y over dx2. So I'll first be able to get f prime with change in x or dy dx of the equation, and that translates into getting what we call the derivative function or the gradient function or the dy dx of that function f in form of x. How do we do this? We just take the power to which x is raised to, then we multiply by the coefficient of x. Just like the way you actually differentiated or found derivative functions or found gradient functions or found dy dx of polynomial functions. It's the same way you're actually going to do this question. So we take the power to which x is raised to, we multiply by the coefficient of what? Of x. And that means 3 times a third. That gives us 1. Okay? So it gives us 1. Then we reduce the power to which x is raised to by 1. So we shall say 3 minus 1. That gives you x2. Then we say less. We shall go to the next part. We take the power, which is 2, multiply by the coefficient of x. So a half times 2, that gives us again 1. Then we shall take now the power and reduce by 1. So 2 minus 1, that leaves us with what? X raised to 1. Then we say plus. So we shall assume at this point we have 1 here, then we have 1 here. The power is 1, the coefficient is 1, because we're just x. So x means it can be 1 x raised to 1. So we shall say 1 times 1, that gives us 1. Then we reduce the power by 1. So 1 minus 1, that is 0. So x gets dropped. But of course, if there's a constant during this differentiation, it is always able to get dropped. In the process of differentiating, we're getting what we call the dy dx. So x gets dropped. So this is our f1 or f prime in form of x, or the dy dx, or the derivative function of that, or the gradient function. So our f2 prime in form of x, or d2y over dx2 will be now equivalent to, again, differentiating this f prime or this dy dx or this first derivative function or this first gradient function. We again take the power we multiply by the coefficient, that gives us 2, we shall write x. Y, we shall reduce the power by 1. So we take the power 2, multiply by the coefficient, that gives us 2, reduce the power by 1 will actually leave us with x. Then we say minus, the power again is 1, so we shall say 1 times 1, that gives us 1. Then we shall look at the power, it is 1, so this 1, that gives us 0, x is dropped. Then the constant is 1, we shall drop that constant. So this one becomes our f2 prime in form of x, or our d2y, or our dx2, or that equation that you can be able to get after the first equation is first differentiating, then that equation that you get after differentiating the first equation again further gets differentiated. So this becomes our final answer. So our f2 prime in form of x of d2y dx2 is now 2x minus 1. Thank you.